Hello and welcome to Astronomy Daily. I'm your host, Anna, bringing you the latest and most fascinating space and astronomy news. Today, we've got an exciting lineup of stories that span from Earth's orbit all the way to distant galaxies. We'll be delving into some groundbreaking research on spaceflight radiation exposure, which could help keep our astronauts safer on long journeys. Then we'll explore how low gravity affects heart cells, a crucial factor for extended space missions. Next up, we'll discuss an unprecedented Seti-study that's searching for alien technology in thousands of galaxies. We'll also take a closer look at our cosmic neighborhood, with new insights into what makes our Milky Way unique. And finally, we'll unravel the mystery of Mars' missing atmosphere. Could the answer have been right under our noses all along? So buckle up and get ready for a thrilling journey through the cosmos. Let's dive in. In a groundbreaking study conducted during NASA's Artemis-I mission, scientists have gathered crucial data on radiation exposure for astronauts using innovative methods. The research team employed mannequins named Helga and Zohar, along with advanced sensors placed inside the spacecraft, to measure radiation levels throughout the 25-day uncrewed journey around the Moon and back to Earth. This data is vital for understanding and mitigating the risks associated with long-duration space travel beyond Earth's protective magnetic field. Radiation exposure poses significant health concerns for astronauts, including increased cancer risk, radiation sickness, and potential impacts on the central nervous system. The study revealed that areas within the capsule designed with enhanced radiation shielding, including a designated storm shelter for astronauts during solar events, provided up to 4 times more protection than less shielded areas. This finding validates the spacecraft's design for future missions and highlights the importance of strategic shielding placement. Interestingly, the orientation of the Orion spacecraft during flight also affected radiation exposure levels. When the craft made a 90-degree turn while passing the inner Van Allen belt, radiation exposure dropped by half, demonstrating the directional nature of space radiation and the potential for mitigating exposure through careful spacecraft positioning. And while on the subject of astronaut health, in a fascinating study, scientists have uncovered new insights into how low gravity affects heart muscle cells during space travel. Researchers sent human bioengineered heart tissue samples to the International Space Station for 30 days to observe the effects of microgravity on cardiac function. The results were striking. The heart tissues exposed to low gravity conditions showed significant weakening compared to their Earth-bound counterparts. More alarmingly, the spacefaring samples experienced disruptions in their normal rhythmic beating patterns. This research provides crucial information about the potential health risks astronauts face during extended missions beyond Earth's protective magnetic field. As we look towards long-term space exploration and possible missions to Mars, understanding and mitigating these effects on the human body becomes increasingly important. The study also offers potential applications for heart research here on Earth, providing new models for studying muscle aging and developing therapeutics. As we continue to push the boundaries of space exploration, this research underscores the need for innovative solutions to protect astronaut health in the challenging environment of outer space. Next up, the search goes on. In a groundbreaking study, scientists have taken the search for extraterrestrial intelligence to new heights, or rather, new distances. The SETI Institute, Berkeley SETI Research Center, and the International Center for Radio Astronomy Research have joined forces to conduct the first-ever search for alien technology beyond our own galaxy. Using the powerful Murchison Wide Field Array in Western Australia, researchers were able to observe an astounding 2,800 galaxies in a single session. This unprecedented scope allows scientists to cast a much wider net in their hunt for signs of advanced civilizations. The study targeted low radio frequencies around 100 megahertz, a range that could potentially reveal technosignatures, telltale signs of alien technology. While no definitive evidence of extraterrestrial intelligence was found in this initial search, the research has opened up exciting new possibilities for future SETI efforts. This innovative approach marks a significant leap forward in our quest to answer one of humanity's most profound questions. Are we alone in the universe? By expanding the search beyond the confines of the Milky Way, we're increasing our chances of detecting any potential cosmic neighbors that might be out there. Now let's take a look at our own neighborhood. The Satellites Around Galactic Analog Survey, or SAGA for short, has recently completed an extensive study of 101 satellite systems similar to our own Milky Way. This groundbreaking research provides fascinating new insights into just how unique our galactic neighborhood might be. The survey focused on identifying and characterizing satellite galaxies orbiting around host galaxies with similar mass to the Milky Way. These smaller galaxies, captured by the gravitational pull of their larger hosts, can tell us a lot about galactic evolution and structure. One of the most intriguing findings is that the number of satellite galaxies in these systems varies widely, ranging from 0 to 13. Our Milky Way, with its 4 known satellite galaxies, falls somewhere in the middle of this range. However, when considering the presence of the Large Magellanic Cloud, our galaxy appears to be somewhat of an outlier. The study suggests that systems with a massive satellite like the LMC tend to have a higher total number of satellites. This makes our Milky Way's relatively low satellite count even more puzzling, hinting at a potentially unique history or characteristics of our galactic system. These findings not only shed light on the Milky Way's place in the cosmic neighborhood, but also provide valuable data for improving our models of galaxy formation and evolution. And we couldn't let an episode go by without a Mars story. So here's today's. In a fascinating twist to the mystery of Mars's vanished atmosphere, new research suggests it might not be lost to space after all, but rather hiding in plain sight right on the planet's surface. Scientists now believe that the red planet's atmosphere may have been absorbed by minerals in Martian clays over billions of years. This groundbreaking theory offers a potential explanation for how Mars transformed from a world potentially capable of supporting life to the cold, barren planet we see today. The process involves a series of chemical reactions where water trickled through certain rock types, setting off a chain of events that essentially sucked carbon dioxide out of the atmosphere. What's particularly intriguing is that this carbon dioxide might have been converted into methane and locked up in the clay surface of Mars. If true, this could mean that the atmosphere is still present, just in a different form. It's an exciting prospect that not only solves a long-standing puzzle, but also raises the possibility of utilizing this trapped methane as a potential energy source for future Mars missions. And that wraps up today's episode of Astronomy Daily. I'm your host, Anna. If you want to stay up to date with all the latest space and astronomy news, head over to our website at astronomydaily.io. There you can sign up for our free daily newsletter, browse our constantly updating newsfeed, and listen to all our previous episodes. Don't forget to follow us on social media too. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok. Thanks so much for listening, and I'll catch you next time for more exciting space discoveries and astronomical wonders. And remember, keep looking up.